last time we ended off, or we talked about anyway, this function f of x equals sine of x over x. And actually last time I called it f of theta equals sine theta over theta, but we're just changing the variable a little bit. That's okay, it's the same function. And what we did was we saw something like this. We saw that cosine of x is less than sine x over x, and that's less than the number 1, at least if x is between 0 and pi over 2. And what I want to start off doing here is I want to show you the graph of this. I can't show it to you exactly, but I'll try to sketch it. It looks something like this. Now, why did I put the hole there? So this is where x equals 0. And if you plug in x equals 0, you'll get sine of 0, which is 0, no problem. And then you're dividing by x, which is 0. And that is a problem. So you may have heard that we can't divide by 0. And you might say, well, that sounds like a challenge. Why not? Maybe we can. So have you ever seen this? I'll show you why can't we divide something by 0. Take the number 1 and divide it by 0. What if it were possible that this had an answer? Well, it'd be equal to something, I don't know. Let's just call it A for answer. And then what I can do is maybe multiply both sides by 0 and do a little cancellation. That's okay. So then 1 is equal to a times 0. And whatever this number is, if you multiply it by 0, it's equal to 0. Now, you can either accept that and say 1 is equal to 0, and you can divide by 0, or you can say, this seems kind of bad. Let's not go down that route. Let's try not dividing by 0. And of course, if you want mathematics to make sense, then you don't want to do this. So we just say that a function is not defined at 0. 0 is not in the domain of the function, and there's a little hole. But you can also notice that, just looking at the graph, and this is the number 1, by the way. So that's y equals 1. So by looking at the graph, you can see that as your x values get close to 0, even though it's undefined there, your y values are getting really close to 1. And that's something you can also see from this inequality. Because if you can look, as x goes to 0, cosine of x goes towards 1. And as x goes to 0, 1 just stays constant, of course. So this thing is trapped between a function that's heading towards 1 and a function that's already equal to 1. And you can see that represented here. And so the way mathematically we say that as x goes to 0, the y values tend towards 1, even though the function's not defined there, that's something that we call a limit. We're going to write the limit as x goes to 0 of sine x over x is equal to 1. And how can you conceptualize this? So once again, the way you'll think of it is by saying that if your x value is really close to 0, then your y value has to be really close to 1. And that's a general definition for what a limit is. Like say you take any function y equals f of x. And I don't know, here might be its graph. It doesn't have to have a hole in it. But say this is the point x equals a, y equals L. So here's a, and there's L. And you want to ask, what's the definition of the limit as x goes to a of f of x? What does it mean to say that the limit as x goes to a of f of x is equal to L? And the answer is that whenever you've got an x value close enough to a, it could be anywhere in the orange range, those are all the x values, then your y values have to be really close to L. And if you can look at the picture, you can see the y values, how far up and down they're going. They're staying in this small little region, aren't they? So here's the graph on the xy plane. Here's the x values, and here's the y values. And these are the coordinates. That's kind of a general definition. Here it is in the specific example for the specific function. And we saw using that argument, remember, with the three triangles, or the two triangles and the pizza slice and the inequalities between them. That's how we got this. And this is like a graphical exploration. You can go online to Desmos or Wolfram Alpha, or just even type in this function into Google. You'll see a graph like that. You'll see the y values approach 1. Now there is like an official, more detailed definition of a limit that's really precise in a separate video. I'll talk to you about that. But for now, I want to give you the idea of what it means for a function to have a limit.